because you are having x is equal to 0, 1, 2, 3 like that, it will have too many values. If x is taking 0 or 1, only two values, we call it as binomial distribution. Okay, so if the data is very large, normally more than 100, so large means statistical, we keep the boundary as 100. If it is more than 100, we will take that event as the continuous event, and usually normal distributions will be calculated. Okay, so this is binomial, and here it should be normal. Okay, standard normal distribution. So you see, writing it as f of x. F of x is equal, we are going to write 1 by square root of 2 pi into e power square by 2. Okay, so we'll take what are the assumptions here is, we have taken this sigma equal to 1, so sigma is this symbol, sigma is equal to 1, and we take this mu, we read this as mu equal to 0. Okay, so these, when you substitute these values, you will get it here, e power minus z square by 2. This is called the standard normal distribution. Again, if you look at that, if you take the value x is equal to 0, 1, 2, 3, 4, this formula will be too much difficult to calculate. So book you can find it. So this is the standard normal distribution table. Okay, so it will have two pages. It will have two pages. If you look at this page, it is from minus 3.9. It's going up to 0. And if you come to the second page is starting from 0, 1, 2, 3, 4 like that up to maximum of 3.9. So this table will be given to you in the examination. First, I will explain how to find the values for any standard normal random variety here. So suppose if you want to calculate the value of, probability 2.732, I want to find the values of z equal to 2.732. Come to the table. In the table, you can see that second page. Come to the second page. Look at this 2.7. 2.7. That is the first two numbers. The first two numbers, 2.7. Look at it in the left margin. Then 3, 2. Okay, don't worry about this 2. Just take this 3. 3, you take it from the top margin. Okay, 0.03. 0.00, 01, 02, 03, 04 like that. Okay, so therefore 2.732, 2.7 here, 3 is in the top, so it is 99683, 0.99683, 0.99683. So that is the value for this z. Okay, so normally the values will be in terms of z, not in x. Why? I tell you later. So 2.7 in the left margin, 3 here. Okay, so there are some big tables where you can find the third value also, but in the exam point of view, even if you are getting a third value, just leave it, don't take that third value. You can take 2.73, 2.7 in the left margin, and 0.03 here in between, 0.99683. That is the value. Similarly, you can find the values for any negative values also. For example, if you want to calculate something like probability of z less than minus 2 point or minus 2.73, if you want to calculate this value, negative value. Okay. So negative minus 2.73 means come to the first page, minus 2.7 here and 0.03 is here. Okay. So 0.00317. 0.00317. So that is the value if it is given the negative region. So try to find this values and put it in the Pyblet. Let us check how many of you are getting the right answers. So take 1.6 here and come to the right, and 5 is here. Okay, so therefore 0.05 is here, so you should take the line from here to here. 6, 5. So we need this value, this one, 0.53. Similarly, if you go for minus 2.98, minus 2.98, minus means the first page, minus 2.98 is here. It is here. 2.98 is 0.00144. 0.00144. 0.00144. Okay, so that is a place we have to go with. So most of it done this. Okay, but the question is minus 5.2. Okay, if you look at the table, minus is going up to minus 3.9 only. Minus 4 is not there. So in that case, what you can do is take this very first value. Okay, any value which is coming less than minus 3.9, minus 4, minus 4.1, minus 4.2, minus 4.3, anything if it is coming, take the first value, 0.4 zeros followed by 5. Very simple thing. 0.4 zeros followed by 5. And similarly, if you go to 0.422, 0.422, in the top side, if you are saying you are getting only 3.9 only, after that we don't get any value. So take the very last value, 3.99. This value 0.497. Okay, 0.497. So if the value is going out of the table, don't think you are doing mistake or something is problem in the mistake. In the negative side, you have to take the very first value. In the positive side, you should take the very last value. Okay, that is, in the line you take the last value for positive values, in the negative values you take the first value. So just remember, these two are the minimum and maximum value in a normal table. Know that the sum of the probability is equal to 1. So we keep this area. You see that this is not touching this line. So this line is not touching this line. There is a small distance. That distance is point. equal to some value. What is the value given in the question? Mu equal to 3, sigma equal to 1, and sigma equal to 1 in the value or probability of x. It should be then so first you should remember this formula in all the questions. Z equal to x divided by sigma. So this formula you should remember. Now in this question what is given? It is given mu equal to 3 and it's given sigma equal to 1. These two informations will be given to you in the question. So now let us substitute, find what is z. And if finding z equal to, take this x is equal to 4, so 4 minus 3 divided by sigma. Okay, so it's going to be equal to 1. Okay, first to find the value of z. Now when the value of random variable is given in terms of x is less than 4. Now we are going to convert this x into z. So z less than 1. You know how to find the value of when probability of z less than 1. Again, let us go back to the normal table. Z less than 1 means it is nothing but probability of z less than 1.00. Okay, even there is no decimal, you can put 00 as the two default decimals. Okay, now 1.00. Come here to the back to the table. In the table 1, okay, 1 is coming here, 1.00. Okay, that is 84134. 84134. Okay, that is the answer for it. So that is the answer for the first question. Okay, so your mu value is 5 and sigma value is 2. When you are substituting everything here, it is x minus mu divided by sigma. So that's going to be minus 6 by 2, that's minus 3. So you x value is less than minus 1 means this in saying that z is less than minus 3. So if we go to the table, giving the value as 0.00135. Okay, that is the excellent answer. Take the same question with a small change. The change what I'm going to do is I'm going to make it as greater than minus 1. So far we have seen all the values less than only. Okay, so if it is coming greater than, we need to make a small change here. Okay, because the normal table will give only the less than values. Whenever you are getting greater than 1, the first step is same. This is same, this is same, this is same, this is same. So when you're coming here, it is greater than minus 1. Whenever it is coming greater than minus 1, we need a step 1 minus probability of x less than minus 1. Okay, so that is a step we should do it always. Very simple thing. Okay, it is a complement of the event. Less than, greater than, it is a complement event. Don't worry about equal to, because this is a large data, therefore equal to will not make any changes. Therefore if it is coming greater than, just convert it into less than. So then it is going to be 1 minus, you know how to calculate the value of probability of z less than minus 3. So that value is going to be equal to 1 minus 0.00135. .99865. 0.99865. 0.99865. 0.99865. 0.99865. 0.99865. 0.99865. 0.99865. 0.99865. 0.99865. 0.99865. 0.99865. 0.99865. 0.99865. 0.99865. 0.99865. 0.99865. 0.99865. 0.99865. 0.99865. 0.99865. 0.99865. 0.99865. 0.99865. 0.99865. 0.99865. 0.99865. 0.99865. 0.99865. 0.99865. 0.99865. 0.99865. 0.99865. 0.99865. 0.99865. 0.99865. 0.99865. 0.99865. 0.99865. 0.99865. 0.99865. 0.99865. 0.99865. 0.99865. 0.99865. 0.99865. 0.99865. 0.99865. 0.99865. 0.99865. 0.99865. 0.99865. 0.99865. 0.99865. 0.99865. is the answer for that? So when you should do this, whenever you are having greater symbol, greater than -1, if it is coming, convert this x into less than by 1 minus symbol. Okay. So, and sometimes what you'll have is you will have a question of this type. Two intervals. It is less, x is greater than 1 and less than 2. If you are getting two intervals like this, the calculation is a little bit different. First, you take this formula is same, and mu is equal to 5, sigma equal to 2 is also okay. Now, when x is equal to 1, okay, so take the first value only, this value on this side only you can take it. So calculate when x is equal to 1, you get x minus mu by sigma, that is minus 4 by 2, it's going to be minus 2. Okay, now again let us take when x is equal to 2, the second value you get when x is equal to 2, z equal to, apply it in the formula, 2 minus 5 divided by 2. So that is going to be minus 3 by 2. Minus 3 by 2 is nothing but 1.5. So that is minus 1.5. So the question given here is probability of 1 less than x less than 2. So here we don't put minus or 1 minus like that. Very simple thing. We will convert this into two parts now. How we are going to convert this? Take the upper limit to whatever number coming here. Probability of x less than 2 always minus probability of x less than 1. So what it is, you should take it in the reverse order with a negative symbol. So take this 2 here and take this 1 here, in between always minus. Now you know how to calculate the value for probability of x less than 2. Probability of x less than 2 you can calculate from the table. So how much is the value? So when probability of x less than 2, let us convert this into z formulas. Okay, it is equal to probability of less than, when x is equal to 2, we got z is minus 1.5. So correspondingly we put z less than minus 1.5 minus probability of, when x is equal to 1, when x is equal to 1 we got z value is minus 2, it's less than minus 2. So z is less than minus 2. Okay. So go back to the table now and find what are the values. Z less than minus 1.5. So table values is here, minus 1.5, minus 1.50, 0.6681. So it is 681 minus z less than minus 2. Z less than minus 2 will be, again from the normal table, z less than minus 2. Minus 2 is here, 0. Okay, so we want to take 0.00, 0.2275, 0.2275. The subtraction for this, that is the last step, 0.6681, 0.6681 minus 0.2275, 0.4406. So that is the end of the problem. it once again. What are the things we have done here? So the question is this: you have to find the value of the probabilities, find the normal distribution of x when mu is equal to 5, sigma equal to 2, find the probability of 1 less than x less than 2. That is the question. The answer is, you should remember this formula always. This is the formula for s. Z is going to be equal to x minus mu by sigma, and it is given in the question equal to 5 and sigma equal to 2. Just copy them. Now there are two boundaries, 1 and 2. Take x is equal to 1, find what is z by use this formula. Z equal to x minus mu by sigma. Z equal to x is 1, mu is 5, 2. Okay, this minus coming from the formula. So when you simplify, take what is that value. Then again take the second boundary, x is equal to 2, put it here, x is equal to 2, find what is that equal to. 2 minus 5 by 2 minus 3 by 2, that is minus 1.5. So now take the given question, probability of 1 less than x less than 2 here. Convert this into intervals, that is upper limit first minus the lower limit. Okay, so this minus always should come. Okay, if it is coming any value here, this 2 here and this 1 here. Now when x is equal to 2, what is the z value? It is minus 1.5. Change this into z. Again change this also to z. Now use the normal table here. So from the normal table, find the values for this, find the value for this, find the subtraction. Okay, so it needs a little bit practice for you. So here average means x bar or mu. Okay, mu is the average. Mu equal to 50,000 kilometers. And it is given standard deviation. Okay, standard deviation means equal to 2500. Okay, so at 2500 kilometer means x less than or greater than actually 52,500. Okay, so this is the meaning, x greater than this one. So we are asking for the probabilities. It is given normal. Use normal distribution. So finally the question is find the probability of greater than 52500. This is the question. So this already you have done. Now this question is given in terms of words. Okay, you just try this and find the answer and take it and give it the option. Okay, so this is the same one.